In this video, we are going to discuss differentiation. Find the derivative of cos AX by using the first principle. So, in this solution, let f of x is equal to cos AX. So, f dash x is equal to, so cos of f of x is equal to cos AX. We have to find the f dash x. So means f of x plus h. So which is equal to cos of a into x replaced by x plus h. So we get here cos of ax plus ah. Cos of ax plus ah. So now f dash x is equal to, we have the formula limit h tends to 0, f of x plus h minus f of x whole divided by h. So now here applying for this function, f dash x is equal to limit h tends to 0, f of x plus h, that is cos of ax plus ah, and minus, so f of x, that is cos ax whole divided by h. Now here in the numerator, if you observe, which is in the form of cos c minus cos d here. See, cos c minus cos d. So cos c minus cos d is equal to, we have the formula minus 2 sine c plus d by 2 into sine c minus d by 2. Into sine c minus d by 2. So here f dash x is equal to, we have limit h tends to 0. We have limit h tends to 0. So this is minus 2 sine. So c, that is ax plus ah, and here plus ax. So whole divided by 2 and sine. So c is ax plus minus ax. So whole divided by 2. So whole by h here. So now f dash x is equal to, we have limit h tends to 0. So this is minus 2 sine. So here ax plus ax. So this is 2ax and plus ah whole divided by 2. And here sine ax gets cancelled. So this is ah by 2 whole divided by, so this is h. So now here we get, see here we get, so f dash x is equal to, minus 2 is constant. So minus 2 into, so limit h tends to 0. So this is sine 2ax plus ah. So this is sine, so 2ax plus ah. So whole divided by 2, and here into, so limit h tends to 0, So this is sine ah by 2, sine of ah, this is sine of ah by 2 by h. This h I am considering sine of ah, this is the sine of ah by 2 by h, for this giving limit there. So f dash x is equal to, so here minus 2 into, so in this if you substitute the limit, so then we get h tends to 0. So this is sine, so 2ax plus here a into 0, whole divided by 2, and here this is like sine 2h by h, like that here a by 2 is there. So that's why here also, so this value is a by 2. This value is a by 2. So limit h tends to 0, sine ah by 2 by h is as per the property. See, we have here the property is limit limit a tends to 0, limit a tends to 0 and sine ax by x which is equal to a, same like that here, limit x tends to 0, sine ah by 2 by h, here h coefficient is a by 2, here x coefficient is a, so that's why we get a here, and h coefficient is here a by 2, so that's why you get a by 2, and this 2 and this 2 gets cancelled. So now f dash x is equal to here minus sine of 2 gets cancelled, minus sine of, so this is 2ax, this is 2ax by 2 into a here, so that's why here 2 gets cancelled. Finally we get f dash x is equal to minus a sine ax, minus a sine ax. Here in this mainly you have to remember that property, limit a tends to 0. So sine ax by x, limit x tends to 0, sine x by x is 1. So limit ax tends to, suppose you can write here, ax tends to 0. So sine ax by x, so that is equal to a. Limit x tends to 0, sine x by x is equal to 1. The coefficient of x is 1 there. So here limit ax tends to 0, sine ax by x, so that is a. So that's why here we get for this one completely we get, so a by 2. So that's why here 2 gets cancelled. So we get f dash x is equal to minus sine 2ax by 2 into a, 2 gets cancelled. So f dash x is equal to minus a sine ax. So like this we can prove that by using the first principle.